Okay, did you get step 1 down?
Okay.
Did you read and understand the problem? All right, let's see if we really truly understand. Everybody see that I've got a piece of tin here. Okay. Now, here's the goal. Again, this is a classic engineering type of question. I've got a square piece, and I'm supposed to cut a corner out of each one, then fold up the edges. The result will be sort of like rectangular prism, like an aquarium. Okay, and based upon the size of the square that I cut out, every single one of those little aquariums is going to have a different value. So, for example, just so you know exactly what we're looking at, I'm going to trim out a little square, random square, and try to make these about the same. So there's the second one. Go.
That's what I was thinking.
What's that?
The red cross.
Like the red cross. Now, I'm going to fold these edges up. This problem with Mrs. Rosie?
Without calculus.
Yeah. It was training you into the concept of the optimization. All right, so we see what we got? See? So with this, what we have is we have a little rectangular prism that contains a certain value. We can fill this thing up. The question is, did I cut out the right size square to have the result be the largest possible volume? Don't know, okay? Our job right now is to figure out for a 10-inch by 10-inch piece of tin, what would be the exact size that we should cut out. And that's what we're going to do right now. All right, so tell me what we know. What should we do? Draw a picture. Save the day. So we have a rectangle, we have a square, and it's 10 inches by 10 inches. Okay, what next? Yeah, we're going to cut these little corners out. Okay. Okay. Do we know how far we're going to cut those out? X. Since we don't know, we establish a value of X. That's the dimensions here and here. Okay? So I'll simulate this side right here by just cutting those out like that. Okay? All right, is there anything else that we can identify? This is the distance, by the way. Since I cut that off, I'm already here. Right? Making sure we see that. Is there anything else we can identify in this now?
Length of that one thing is 10 minus 2x.
Does everybody see that one has to be now 10 minus 2x? 10, take away the 2x's. That's the length of that. Okay. What else do we know or that we can identify that would be important in this problem? Careful. We volume, because the end result is a volume. Okay, what's the volume of this shape? Length times width times height. This is a rectangular prism, so it's length times width times height. Okay. All right, we've identified everything that we know. Let's identify what we want to know. What do we want to know? So in other words, we want to maximize the volume. That's what we want to do. And in the end, we're going to get the x value that makes that true. Okay? So this is critical, a critical step. When you're doing your own homework and you're saying, all right, identify what we need to know, because this is going to lead you into the equation that you have to create. In this case, we have to create an equation. What equation are we going to use? Since we want to maximize the volume, we're going to use the volume equation. Okay? So we're going to say this, V of x is equal to, it was length times width times height. Okay, back to the original problem. Now, I don't know about you, but this is kind of hard for me to see, so what I'm going to do is I'm going to make a 3D model. This is how I would look at this. If you folded all those edges up, you'd get something that looks like this, right? Fold them all up, we get this. Okay, so help me out here. What is this dimension? That's 10 minus 2x. What is this dimension? Also 10 minus 2x. And then what is that dimension? X. Does everybody see how those two relate? Sometimes redrawing it in a different manner helps. Okay, here we go. Length times width times height. Well, that makes it a lot easier. So here, I'm just going to write them in this order. X times 10 minus 2x times 10 minus 2x. That's our length, our width, and our height multiplied together. This is the equation that we're going to maximize or minimize. Okay? And actually, the one that we're going to maximize, because we want to find the largest volume. Okay, how do we do that? Find the derivative, set it equal to 0. Okay. Now we got several ways that we could do the derivative on this one. Give me some options.
Just, yeah.
Should we just crank it out and then find the derivative? I think that's probably the easiest one. We could do actually product rule where everybody gets to be the derivative. That would actually work out with those three. But let's just simplify that first. So here we go. V of x is equal to, I'm going to leave the x on the outside for right now. Those two guys are the same. That's 100 minus 40x plus 4x squared. And then distribute that. That. And I think just for fun, I'm going to switch this thing around. 4x to the third minus 4x squared plus 100x. And this is our function. All we did was rewrite it. We didn't take the derivative yet. All right, so what's the derivative?
12x squared minus 80x plus 100.
Good. Set it equal to 0.